Okay, the new video is about flat roofs or terrace floors. Roofs which have a slope lower than 5% may be called as flat roofs or terrace floors. Okay, if we will use the top of them as a usable space, it's better to call them as terrace floors. If it will be left as a roof only and it will not be used as a space, we may call it as a flat roof. Okay, so again, what will we have? We are going to have a reinforced concrete or steel structured roof, like a steel composite deck type of a roof or floor. I will shoot new videos about these floor systems, and we are going to turn the top of it into a roof. It doesn't matter if the structural system is reinforced concrete or steel, the top plane that we have there will probably 90% going to be made of concrete. So in terrace floors, we need to keep in mind that there's a very important wall need to be constructed there, which is called as a parapet wall. Now parapet walls may be produced from masonry structures, or if you say that we are already going to cast concrete there, they may also be cast in structures as well, RC. Okay, they may be masonry or cast in structure. If they are cast in structured, we are entirely going to draw it like this. If it is a masonry one, we are going to draw it like that. And don't forget that you need to draw the elevation lines also. Okay, so what we need to do now, we need to think about the performances, and water related performance is very, very important, and thermal performance is also very, very important here as well. Okay, because this is a room, and this is open air. We now need to make this plane both watertight and thermally insulated. Okay, so in these types of roofs, terrace floors, flat roofs, we need to use special and very strong waterproofings. Okay, and those are not permeable membranes like we use in pitched roofs. Okay, so we will use membranes like PVC membrane, PVC waterproofing membrane, a plastic sheet with a thickness of over half a centimeter, around 1 centimeter, or we may use bitumen membrane, or we may use cementitious waterproofings. In the world construction industry, bitumen membrane is the #1 choice of constructors and architects. And in terrace floors, we need to make these sloped, because water will arrive to them and we want the water arriving to them to flow and reach to the rainwater drainage system and leave our roof system. That's why under the waterproofing membrane, depending on the type of your terrace floor, we will probably going to use a slope screed. Okay, so let's write it here. Slope screed. Okay. In some magazines, you will see that they may be defined as concrete to falls. Concrete to falls. Okay, so these falls are the falls, atmospheric falls, like rain, snow, hail. Okay, and concrete is concrete. So concrete being placed for rain, hail, and snow, it means. Okay, and that is what we call a slope screed. Okay, so I like to use slope screed or sloped screed more than concrete to falls. Okay, again I'm going to draw a larger scale of that part. We have got the cast-in parapet wall, we have got our reinforced concrete slab, and we are going to have our beam here. Okay, and this is the column, that's the beam in the background. Like that. Okay, first things first. Okay, but before talking about that, there is a categorization of terrace floors according to the placement of waterproofing and thermal insulation. Okay, so we have got normal terrace floor layer organization, terrace floor layer organization. In this organization, we have got waterproofing on top, we have got thermal insulation below, and we need to have a vapor barrier below the thermal insulation. Okay. Alternatively, we have got inverted terrace floor layer organization. In that one, we have got thermal insulation and waterproofing. Okay, and as the waterproofing is going to also act as a vapor barrier, we do not need to use a vapor barrier anywhere in these roof structures. Okay, but as in inverted terrace floor layer organization, the thermal insulation will possibly get wet. We need to use a thermal insulation which is not going to absorb water into its body for continuing as a thermal insulation material. Okay, so probably it will be an extruded polystyrene. Whereas in normal terrace floor layer organization, as the thermal insulation is going to be kept dry by the protection of waterproofing above it, we may use many different alternative thermal insulation materials like stone wool, EPS, XPS, and others. Okay, now what will we do? The first thing that I will do, I'm drawing it a little bit exaggerated. Okay, the first thing that we will do is placing a slope screed on top of our floor. Okay, now I have drawn the slope screed exaggerated. The highest level of slope screed, that's called the slope screed. The highest part of it, the slab, the slope screed, okay, needs to be smaller than the slab, because we don't want to load our slab with great weights of slope screed. And waterproofing materials do not like turning narrow or perpendicular angles. So in order to make it turn a wide angle, okay, in order to prevent the waterproofing to turn narrow angles, okay, or perpendicular angles, in other words being folded, we need to add here a layer of concrete. We need to put there concrete, or we need to give there an angle like that. Okay, so it is going to be practical to give it with concrete, but we can use a piece of triangular in section wood as well. Here I'm going to draw it like it is wood. Okay, and then what will I do? I'm going to draw inverted terrace floor drawing. I'm going to place my waterproofing. Be careful, I have turned the waterproofing a little bit up. Let's extend it more, like that. Okay. Because the water may possibly be collected for a couple of centimeters, and I'm going to add layers here, and I don't want the collected water to try to enter into my building from the intersection point of waterproofing and the parapet wall. Now that I have covered my entire terrace floor with thermal insulation, with waterproofing, I'm going to place thermal insulation. Like that. Okay. And now that I have my thermal insulation being placed, I'm going to finish my terrace floor with natural stone. These are my natural stone tiles, okay, which are glued to my roof by the help of mortar. And I add here a skirting, again made of natural stone. Let's extend our parapet wall a little bit more, like that, and let's extend our waterproofing there as well. Don't forget that the skirting also turns, and it is in elevation, and don't forget that the parapet wall also turns. And here I'm going to cover the top of my parapet wall with a coping. And I'm going to shoot a video about copings later. Okay, now I didn't like this detail very much, okay, because there will be a thermal bridge like that. Okay, so in order to correct that, what we can do is, before placing these layers, okay, and before placing our mortar and the natural stone, and of course the coping, we can cover our parapet walls inside with thermal insulation, and then I can place my mortar, my natural stone tiles, the skirting in its place, and the coping may come like that. Okay, and of course don't forget that we have got a wall there, and we are going to have thermal insulation coming from there as well, and we are going to make the thermal performance continuous. Okay, that's all for today. Okay, we didn't look at the normal terrace floor layer organization. That's pretty rare to be used in the majority of building structures. So if you have got a terrace floor, probably you are going to choose a terrace floor of a normal size building, like an apartment building of 510 15-story site, probably you are going to use an inverted terrace floor. I will shoot a video about normal terrace floor layer organization in a different time. Okay, so this detail that we draw here is representing the inverted terrace floor systems. See you later.